Okay, so welcome to our ADSA Open Research, Open Scholarship SIG meeting. We're here today talking with Vicky Rampin about ReproZip. And I'm going to hand things directly over to Vicky so that she can get us started. Take it away.
Yeah, thanks so much, Steve, and thanks, ADSA, for having me at your SIG. I'm really excited to talk about ReproZip. I'm Vicky Rampin. I'm the librarian for research data management and reproducibility at New York University. I'm also the subject specialist librarian for data science. I've linked my slides in the chat, so hopefully you all, if you'd rather follow along that way, you're welcome to. I'm also going to share my slides and just go over a little bit about the problem area of what we're trying to solve with ReproZip and what the tool actually is. So this is me. I care deeply about open and equitable access to scholarship, and what I think that requires is everything from code to data, documentation, and everything in between. So all the things that underlie a research process. Today, I'm going to talk a little bit about ReproZip and Reproserver, which is a new tool that provides access to materials packed with ReproZip. And then I'm going to go over some of the context why reproducibility matters, things like that. So let's just jump right in. I'm going to give you some context to the problem area. But before I do that, I'm going to tell you definitions. So I want to make sure we're all on the same page when we're talking about reproducibility. Reproducibility is when independent people from the original authors use the same research materials and conditions to verify a claim. So in the real world, this is when, for instance, if you're someone submitting to a journal and you have a peer reviewer, and that reviewer reruns your code with some data during the peer review process to double check that the figures they get match the figures you got in the paper. So it's not necessarily trying to verify that like capital T truth of what you're saying, but just the specific claims that you're making. So that's reproducibility. That is in contrast to replication, and a lot of people use them to mean the same thing, which is why I'm telling you how different they are now. So I'm not considering them the same. But replication is when independent people use different research materials collected the same way to try and verify a claim. So this is about adding to the body of work around a certain topic to try and get at that capital T truth. And so this is when, for instance, someone reads a published paper and they want to use the same methodology to try and validate that scholarly claim. So it adds to like the pro or the against. However, like all things, I like to define reproducibility on a spectrum, going from reviewable to open and reproducible. And these definitions come from the Lotin et al. 2013 ISERM report, which I really like. I think it's great context for the whole conversation. So if we think about things as reviewable, reproducible, not reproducible, I think we miss a lot of nuance in between. Some things can be more or less reproducible for very valid reasons, like if you're working with sensitive data and you can't make that available to a reviewer to check your process. Your research might just be reviewable, which is what we have now. Like we can read your paper, we can look at your code, and that's it. Like we can't necessarily say if it's reproducible or not, but we can at least review what you have. Going down towards the more reproducible end of the spectrum, the Lotin et al. Team refer to replicable as reaching those original materials reaching the original results with the original materials. Confirmable is reaching those same results without. And auditable is really what we want to get towards. So where we can actually look at your whole workflow holistically, where we can say in your data analysis process, how did you get from A to B? Give us all those materials, give us those tools, tell us the process, and we're going to try and go end to end. And open and reproducible work is when that auditable research is made public so that anybody can try and check the end-to-end process of your scholarship. I also think of it in terms of like a pyramid of what is necessary to achieve these things. So what is necessary for reviewable research is really just the article, which is the default of what we have now in publishing and in scholarship. To have something be replicable, you really need the code and the data, because often for a lot of data intensive work, the code is the methods in so many different places, or we're applying new methods in different computational settings. For confirmable, we really need documentation, because if you give someone a piece of code and data and just say, have fun, there are probably a lot of things in flux, like if your column headers are SAM and the secondary reviewer has no idea what that is. We need documentation to provide context and to provide information about your data, about your code, about your process, such that we can follow it as closely as we can, as necessary, or so we can understand it better. And then at the bottom of the pyramid is the computational environment. So when we used to when we conducted research primarily with analog materials, so materials that like exist in, it's so weird saying exist in the real world because digital materials exist in the real world too. Physical materials, let's say that. So when we used to work with physical materials, the actual physical environment was very important to understanding sort of the rest of the method or the result, right? If the temperature in the lab was off by 20 degrees, maybe your results were different. However, we're doing a lot of our scholarship on computers these days. We are running simulations, we're doing statistics, we are tagging things with qualitative software. And so the physical environment becomes a lot less important, and the computational environment becomes what's actually important to make sure that we can reproduce things over time. So if you've ever tried to go from like Mac to Windows, you might understand why the computational environment is important, and how things can change a lot when trying to move from one to the other. So we sort of need the whole pyramid for reproducibility. Most of reproducibility, I will say, is just data and code management. It's nothing fancy. It's documentation, it's good file formats, it's backups, it's things that are daily practices that aid with reproducible builds and with making that knowledge exchange easier. But no matter how great your data management is, it actually can't really help you that much with the computational side of things. You can't give someone a copy of Mac with your code and your data usually. So this is an area that needs some special tooling and some special education and training as well. And it matters. So this was a great story from Ars Technica, which looked at around 160 papers in chemistry, where they had some Python scripts associated with the articles. And they looked at the scripts and found that the actual results of the analysis were off by nearly a full %, depending on the operating system that you were using to run them. So we can see that actually, you know, the environment affects the actual scholarly result of your work. The result of the analysis is dependent on where you're running it. This is both scary and good to keep in mind. It also points to the problem of dependency hell. So the problem with these Python scripts was actually one specific dependency that made the whole thing not reproducible. And it was this thing called the glob module, which I love. Glob is hilarious to me. The glob module, basically all it does is it searches for files that match a pattern and returns it. But the way that they return it, the order that they return it, is different depending on the operating system. And so this actually affects the whole calculations of the whole rest of the script in a way that makes the results irreproducible. We didn't actually verify, these folks from Ars Technica didn't actually verify whether or not the results could be reproduced that much. So there are around 160 affected papers in this, but it's not the only discipline. It's not the only case of this happening. And I give a lot of horror stories because I usually talk to students and it's a good motivator. So forgive me for all the horror stories. But just so you know how deep this problem goes, this is another example of dependency hell. So the idea that there are all these nested dependencies that we may or may not know about. And I'm sorry, these are very small graphs, but they are also in the slides. There's a link to the paper. And this paper is called The Effective Reproserver Version, Workstation Type, and Macintosh OS version on anatomical volume and cortical thickness. So basically, it's a paper that looked at this one software called Reproserver. And Reproserver measures anatomical volume and cortical thickness. So it's a neuroscience paper. It's a neuroscience software. And this group, Gronin Child et al., tested the same process, the same research workflow on using different versions of the tool on the same operating system, the tool on different operating systems, like different versions of Mac OS, and then the tool on actually different hardware, like whether it was on an HP or a Mac, an Apple computer itself. And there were significant differences in the results. If you look at the bottom version, it actually, each of the colors of those bars are the results depending on the version of Mac. And they are all over the place for these specific measurements that they have at the bottom. So you can see the actual computational environment heavily impacts the results of your research. So there are around 4 different types of reproducibility tools that try to address this problem. The first are containers, and these are just portable operating systems. They're lightweight, and they're really good for short-term sharing of computational environments. Containers were made to be destroyed and recreated at will. And so these are not necessarily a long-term solution, but they have been used pretty heavily in conjunction with other tools and to facilitate short-term sharing. An example is Singularity or Docker. Singularity is used in academia a lot because you can run it on high-performance computing systems, which is why I mention it here. There are also tools that are called what I call web-based IDEs, web-based integrated development environments. So these are basically websites or platforms that you can go to that you can run code. You can run code in your browser. They have a place where you can, for instance, upload data, and you can then usually like share it out to facilitate rerunning of code in the same computational environment in your browser. So this is like Wholetail, for example. This is also CodeOcean would fall into this category. I think those are the 2 main ones right now in the landscape. So these are things where you do all of your work actually in the browser. So you start and finish in the browser. So you can see it already lends itself to different use cases off the bat. There are also web-based replay systems. So this is like Binder, where you have a browser-based tool that lets you rerun research that's hosted elsewhere. So with Binder, for instance, the materials are hosted on GitHub or Zenodo or Dataverse, and you provide a link to them to Binder, and then Binder reruns it for you. But Binder's not hosting the materials. They're just replaying it for you. This is different from the web-based IDEs where actually everything is hosted there, and you're actually doing all the work in the web. The last class of reproducibility tool, I think, is packagers. So these are tools that will basically bundle all of your dependencies together into a shareable package. That's why they're packagers. And that's what ReproZip is. So that's sort of where I'm going to spend a lot of the time today talking about. And if there's no questions, I will move on to discussing what ReproZip is and how it can help with these computational problems. So are there any questions so far? Okay, good. Okay, I'll move on. So now let's talk about ReproZip and why it's useful. So ReproZip is an open source tool originally developed in 2013 at NYU by Fernando Chirigati. Vicky Rampin is now the full-time, or he has been since 2014, the full-time developer and maintainer of ReproZip. And ReproZip was created originally to serve reproducibility after the fact. So the idea is at the end of a project, you could use ReproZip to make your work reproducible. And it's meant to integrate easily into existing workflows because of that specific design principle. So what ReproZip does is it captures and packages together all of the dependencies of your research, even like weird modules like glob, and it packs it all into a small bundle called an RPZ file. This RPZ file can be published, can be shared, and what it will do is automatically set up the original computational environment on somebody else's machine and rerun the research. So it's automatic packing and it's automatic rerunning. Some nice things about ReproZip is that it also captures provenance and order of execution. So if your research is like 3 scripts in a row, you can capture that with ReproZip very easily. And ReproZip will keep track of which script runs first in which order, for instance. So it can be really nice in that it's aware of your workflow. It can show other people your workflow. And it has all of the dependencies within this one bundle that is easily shared, for instance, with reviewers or collaborators to facilitate reproducibility. ReproZip is part of a larger ecosystem. So there's ReproZip, which facilitates creating this reproducible compendia, this zip file basically that contains everything needed to rerun your work. And there's two ways that people can interact with ReproZip. The first is with these bundles. The first is in Reproserver, which is basically a website where you go, you pass it a link to a ReproZip bundle, or you upload one, and then you can unpack and rerun it in the cloud. So it will automatically display the workflow for you. You can rerun it. You can verify somebody has the right result. Or you can use ReproUnzip, which is a desktop tool that will allow you to explore the research packed in the ReproZip bundle. So you can use Docker or Vagrant, or you can just unzip it and see the contents. So there's lots of different ways that you can interact with research once it's packed with ReproZip. So this is sort of the high-level overview. So you work normally, you're doing your analysis, everything's great, you're processing, it's all done. Once you're done, at that point, you would use ReproZip. You would run ReproZip trace, which finds all the dependencies of your research. So for instance, if you are using Python and you're using scikit-learn to do some machine learning analysis, ReproZip will not only trace and pack the Python interpreter that you're using, like Python 3.5, let's say, although you should probably be past 3.5 by now, 3.7, it will pack the interpreter, it will pack the source code, it will pack the source code of all the libraries that you're using. So it will pack the source of scikit-learn. And once you use that number 3 ReproZip pack, it puts all of that source and all of the metadata about it into a small shareable RPZ file. And then all you do is you publish it. So you put the RPZ file in a repository of your choosing, and then give someone the link and sit back and watch them perfectly reproduce your stuff. So that's the high level how ReproZip would work in pretty much anyone's workflow. ReproZip can pack pretty much anything you can run on a computer. We haven't yet found something it can't pack, although for high performance computing environments, the packing is a little more complicated to set up, but it's actually doable. We've even packed proprietary software, although we can't distribute it because it's proprietary, but it packs quite a lot. Pretty much any data analysis script or software, any graphical software or interactive tools, any like websites with databases. You may have seen some work around saving data journalism with ReproZip, because specifically it can pack the those client server applications. There's a Jupyter Notebook extension for ReproZip where you just have a button and it perfectly packs your Jupyter Notebook, and more. So like I said, if you can run it, ReproZip can likely pack it. And this is how it looks in a little bit more detail. So you start with some research process. You would execute ReproZip. And again, you're tracing not only the environment variables, what's going on with the computational environment, but you're tracing and packing the steps that the researcher took, the input files, the output files, the different parameters that they're passing in their research. So you're getting all of this, and it goes into a configuration file, which is basically a ginormous YAML file with like all the technical metadata you could ever dream of. And ReproZip uses that to create the computational environment after the fact. But it can also be used in lots of other contexts to be transformed into other different types of tools, for example. So for instance, ReproZip packages can be easily imported into lots of different systems because of the configuration file and how generalized the metadata is that we pack. So at the end, you get this reproducible bundle. And once you send that to somebody, they can, on any operating system, use ReproUnzip or Reproserver to automatically recreate the original computational environment. That's what ReproUnzip does, and then allows you to interact with it. So you can do like the click and reproduce. But another thing about ReproZip is that you can actually extend the unpacked research. So you can upload new inputs So if someone's doing research similar to yours and you've reproduced it with ReproZip and you want to test out their workflow on your data, that you can do that. This is what the desktop application looks like on Linux. So there's an upload a replacement button. You just upload a replacement of the data. You can also download new items to or you can download the output of anything that you have tried as well. So if you try something and you want to get the results back, you can always get things in and out of the bundle very easily. So I have a little example. It's going to be a YouTube video and a YouTube video, which is pretty funny. A little example of how it looks like to pack a Jupyter notebook with ReproZip. So this comes from Ariel Rokum at University of Washington, who I always use his stuff in ReproZip. There's a little button that says trace this notebook. And all you have to do is click that. And what it does is it's doing that same process. So it's tracing all the dependencies. It's going to run the notebook from top to bottom. And it's going to create this RPZ file signal formation right there, which you can see once I flip to the tab. And there's this nice little RPZ file. It has the name of the notebook and the date and time that it was packed. So once you pack your research with ReproZip, then you can, like I said, unpack it. So that was on Linux. This is Mac. So 2 different operating systems, same RPZ file. I'm going to use Docker and I'm going to unpack it. All this does is it writes everything out to a different folder there. You can see a folder was created. You can run the notebook server. And then in the one click, you'll be able to fully reproduce this person's work, Ariel's work from Linux to Mac. And so that's sort of the big draw of ReproZip. We can run this. It will run exactly like normal, exactly like it did on Ariel's notebook, Ariel's computer originally. I have another example of packing plots from Digital Humanist. So ReproZip supports a lot of use cases. So this is what it looks like to pack an R script. So this is the command. You just prepend ReproZip trace. And like I said, it will do the tracing automatically for you. We can see the results, beautiful plots. ReproZip pack, you give the package a name, and that's that. So again, and that's what it looks like, the little RPZ file. You can unpack it in the command line as well as the GUI. So with the notebook, we showed you the GUI, and this is how you would do it on the terminal. So this time I'm using Vagrant, and I'm using it to set up the RPZ. And what it will do is right now, all it's doing is downloading and installing all of the dependencies of the original script inside of a brand new Vagrant machine for me. And this is how you are able to go from operating system to operating system. And so now I'm going to run the scripts. It worked perfectly, yay. And now I can download all the results. So I can verify that the plots that this person, Nick Wolf, submitted with his paper match the plots that I got from his RPZ file of trying to look at it. So I can flip through all the 7 plots and it looks right. Cool. All right. Yes, that's it. Okay, cool. So now I'm going to talk about Reproserver, which is one way that we have tried to simplify accessing ReproZip bundles. So to create them, you saw it's one click on Jupyter Notebook. It's 2 commands on for command line applications like ReproZip trace and then ReproZip pack. But there are lots of options for unpacking them. And so we have a lot of journals and conferences that use ReproZip. And we had a lot of requests to simplify the method of unpacking ReproZip. They wanted a one-click like unpacker. And our approach was Reproserver. So Reproserver is one way to rerun work packed in ReproZip in the browser. So Lotin, you don't have to install anything. All you need is that RPZ file or a link to the RPZ file. It allows you to do all the same things you can do locally, just in the browser. It offloads the archiving responsibility to people who are good at it. So we're not hosting anything. We're saying post it in your institutional repository, Zenodo, the OSF, anywhere, and just provide us a link to it. That's all. Once we have the link, so this is how it looks basically. So you provide a link or you upload the bundle, you click unpack. you're going to see on the web the different parameters and the different workflow steps to the package. And then you run it and you get the output, and you can verify immediately whether or not it is reproducible. So I have a short little other video about unpacking with Reproserver. So in this case, I'm uploading a file that has a machine learning operation to recognize handwritten digits. When you click unpack, you can see there are two scripts, one to make a classifier, one to actually recognize the handwritten digits. You can see the log if you need to change anything. You can give it new parameters. Those are the input files. You can see there's even a little MATLAB file in there, .mat. And here are the outputs. So you can see how it worked. You can look at the output. It looks like it correctly matched the handwritten digits, which is cool. But you can also change the input files on here too. So if I wanted to test this with my handwriting, for example, I could. So if we upload a new input and try and rerun that same workflow, that's actually not an error, even though it says error, which is funny. And we can check the new output file to see how it worked. And you can see that, yeah, it actually did work for my data. Very cool. So that's just one example of how you can use Reproserver to verify reproducibility, but also to extend your own work. And you can see it again too for the Irish schools example. So the national schools, it's on the OSF. It has an OSF link. All I need to do is copy that, and I can run it directly in Reproserver with the -reproduce and then pasting in that link. So you can actually even directly provide some links to different repositories to do like the exactly one-click reproduction with Reproserver. And then it's just going to run like normal. So in summary, reproducibility is hard. There's lots of factors and practices. People don't reward you for being more or less reproducible, but it is a foundation of trust, of verification, and it's worthwhile. And ReproZip and Reproserver are two tools that can help you do that, help you achieve reproducibility. So with ReproZip, you can create that RPZ, that fully reproducible bundle. And then with Reproserver, you can provide access to those materials in your web browser. So there are some current use cases of ReproZip and Reproserver. It's been used to facilitate peer review. I mentioned conferences and journals. So some journals, for example, are the Journal of Number Theory, Journal of Complexity, and a conference is SIGMOD that uses ReproZip for peer review of their materials. We have a gallery of examples as well for you to see how ReproZip has helped facilitated reproducible research across different fields and different workflows. It's used in other people's infrastructure. So it's used in the cloud of reproducible records to do the reproducibility part. It's used in digital preservation to provide entree into different systems, like emulation as a service infrastructure is really interesting. It's a system that allows you to access old software and old operating systems in your browser. And you can actually import ReproZip bundles into emulation as a service infrastructure. So if you want to use a ReproZip bundle in 20 years, import it into Easy and you can get the old operating system going pretty nicely. So that's a long-term goal. But the interoperability is there, which is great. It's also used in other computational science tools for use cases we didn't imagine, but really love, like NeuroDocker. They use it to minify, to make like smaller Docker containers. And in Spot, they use it to actually make different provenance graphs, which is pretty cool. And Wholetail uses ReproZip to actually create metadata and to query it at scale. So people are using ReproZip in really wonderful ways, even outside of like one-to-one reproducibility. And if we look particularly about the peer review use case, because there's a great current example of this, basically what we've set up with these journals is facilitating the author makes the RPZ, you follow the packaging steps, they either submit it to a repository or they have it as a part of their article submission. The reviewer reruns the RPZ so they can use it with Reproserver or they can do it locally just to verify that the results match what the article says. And then the reviewer reviews like normal. And we actually they used this recently in SIGMOD's programming contest, where they asked participants to solve a problem. They provided them some data sets to solve that problem. They submitted this work using ReproZip. And then actually the reviewers uploaded a different data set to test the model itself. So this is one way to not only do the review of the programming contest, but also try to extend the different models created by the participants. So this was this year's SIGMOD and how they used ReproZip as a part of their contest, which is really cool, I think. Great, brand new, hot off the press use case came out yesterday. So that's it from me. I'm happy to take questions. I would love for you to try out ReproZip and Reproserver and test Unpacking as well. We have some examples on Reproserver already. If you go there, you're more than welcome to email me or tweet at me or find me where my code is. I'm Vicky Rampin everywhere. So thank you very much.
Great, thank you, Vicky. So we do have a few questions in the chat, and then we're a small enough group that we could maybe just unmute and ask our questions and discuss. Michaela, do you want to go first, and then we'll go to Mohammed?
Yeah, sure. So I dropped my question in a little early along, but I think it's still kind of relevant. I was just curious if there's like a templated or recommended format for the documentation, right? So a user wants to use an RPZ file. I realize you went through it and it's really pretty simple to unpack, but maybe some of the details of the research, that sort of thing.
Yeah, absolutely. So we have the examples.reprozip.org. And let me share my screen again, actually, because it's kind of relevant. And so this is our gallery of examples. And if you click into one of these, you can see an example of how we've documented how to use it. So there's the ReproZip package. We say, here it is, and how big it is. They're usually under a gig. We haven't had one that's very big. And then we provide some step-by-steps of how they can reproduce and interact with it. So folks are more than happy to pull from our examples repository for their own, but we don't have a set of templates. We have documentation, of course, docs.reprozip.org as well, which go through everything I've talked about in way more detail as well. So I think those were the two most relevant to that question.
Great, thank you.
Yeah, no problem.
Mohammed, do you want to ask your question?
Awesome, yep. Thank you, Vicky, for the great presentation today. Really appreciative and very insightful. Now, I did have a couple of parts of my question. I think implicitly the first part was answered. It was about whether the system's cross-platform, and yes, you actually provided a demo that worked well for that way. But my second part of the question was how it deals with source files that were built to run on one platform. Like, for example, you have a C++ file that was built on Windows, and I have also I have used Docker personally extensively, so I know that when it comes to setting the GUI variables or displaying a GUI from a Docker, it's very challenging. And I want to say it's not challenging in how you can do it, but it's challenging because it depends on each platform that you would run it at. So you would have to install or use Xterm, for example, or Xquartz. If you're using Mac, you would have to install Symrel X11 terminal service if you're using Windows. So how the system really works with these platform specific situations that are not even solvable within Docker.
Yeah, so what ReproUnzip does is it recreates the original environment. So right now you can only pack on Linux and Mac, or on Linux rather, because we can only redistribute Linux. We haven't found a safe way to create RPZ files from Windows and then redistribute Windows with those bundles, right? So there's some questions there about the legality of packing on different operating systems, but I can answer it for Linux at least, which is what we do is we are recreating the whole environment. So when we're running ReproUnzip, what it's doing is it's setting up the exact version of Linux that I used, with all of the dependencies of that operating system. So we're exploring packing on Mac and Windows right now. Actually, Windows is more likely to happen first than Mac, which is really funny. Windows has a great automated tool for debugging that we actually think we can use to trace some processes. But basically what we're doing is tracing at the system level in order to identify and package some of the dependencies that you were mentioning, and then automatically set them up in a different place. Does that answer your question?
Yes, yes. So I
Okay,
you know,
great.
the perception that I got, it's still some sort of work in progress, and eventually
We have
it will be
some
there.
stuff to do. Yeah, so we definitely have some future work. We want to be able to pack on Windows and Mac. Those are mostly licensing problems, frankly. Mac is a technical problem, but Windows isn't. With proprietary software too, I see that Steve asked, like, we can pack it. There's actually no conflict in rerunning, or we had conflict with MATLAB, and I think that's because they had some secret sauce in there that we don't know about. But we've successfully packed and unpacked other proprietary software, ones that like I've gotten a license file for, because what we tried to test was packing a proprietary software with an RPZ file, sending it to someone with a license key, and then using their own license key to reproduce. So it wasn't exactly a successful experiment, but it's something that we are trying to consider in greater depth, I think. Yeah, does that make sense? Does that answer?
Yeah, it does.
Okay.
It does. Thank you.
Good. Yeah, no problem.
So Vicky, I was also wondering is this project an open project? Is this something that people can contribute to and participate
Yes.
in, not just as users,
Absolutely.
but as contributors?
Yes, 1,000,000,000%. Let me drop the GitHub link in the chat. We have some pull requests in there from several community members that we're working on merging in. That's really exciting. So definitely feel free, anybody watching this, to contribute. It's an open project. It's on GitHub. We accept issues as well. So if you're looking just to provide feedback or to tell us about a use case that you would like us to support or talk to us in any way, you're welcome to submit an issue on GitHub. You're welcome to email us, and you're more than welcome to make pull requests on the repo. And Remy is the one who manages that process of merging it in, of testing and communicating with PR authors.
Great, thank you.
I think maybe, do you want to just read off that GitHub link, because
yeah,
the recording doesn't capture chat. Or
yes, good point. It's github.com/vida, like life, VIDA -NYU /ReproZip, ReproZip.
Vicky, do you have any how's uptake going? I mean, you have a gallery there. You said there are some folks using it, and you've got some journals and whatnot, which is pretty incredible. But do you have any sense for? Are you building momentum? Is it? What's
definitely.
going on?
So we have there have been a number of different articles of folks who have used ReproZip to facilitate reproducibility of their work. It comes across my desk in the Google Scholar Alert, which is always really exciting. So we see it increasingly being used out in the community. And I think what's exciting for me too is that it's increasingly being integrated as a part of other infrastructure. So like with the example of the Cloud of Reproducible Records, or with Easy, or even like Wholetail, those are other initiatives trying to work on reproducibility with slightly different motivations, slightly different angles, slightly different goals. But they all have found ReproZip a software that is both worthwhile to integrate with and easy enough that they can do it without talking to us. And those to me are two really strong indicators that it's like a high quality software, not to toot Remy's horn, I guess, because it's Remy really who wrote it. But yeah, it's definitely, we've definitely got more requests, requests for speaking engagements too. So I definitely feel momentum for a tool like this.
Yeah, that's great.
And for ReproZip in particular. And it's cool too, because for instance, ReproZip bundles that were packed in 2013 still work. So it has some longevity itself to the materials that it's creating too.
That's interesting.
Docker containers from 2013 don't work. I'll just say that.
Yeah, that's sort of, that brings up a question about how do you test longevity for something like this, and it's sort of not possible unless you just wait. Or,
Well, I think
yeah.
I was just in, right before this, I facilitated a conversation about scholarly publishing and reproducibility for the ACM. And Dan Katz was there and mentioned some initiatives for ongoing checking of reproducibility. So he described it as not a badge, but a flag, which I liked. So instead of having a badge saying like, this is reproducible, you would have a flag. And every so often you would try and rerun the research. And if it failed to reproduce, like the flag would be taken down. And if it was fixed, the flag would go back up. So it's less of a static, we checked it once during peer review, here's your badge, and more of like an ongoing check. That requires a lot of things. It requires a tool that can automatically check and return some stuff, or facilitating. It needs some resourcing and people on board. But I actually like that model as a way to promote like a healthier view of reproducibility. I don't think it should just be like check before peer review one and done. If people are building on the methods, on the conclusions, then it should probably be checked a little more often. So I like the idea of ongoing maintenance and checking of reproducible results.
Yeah,
but I don't know exactly yet. I don't have a pie in the sky vision of how I would do it.
Right, right. Great. Any other questions for Vicky? Sounds like not now, but maybe some of the viewers on YouTube will be able to send you questions by email.
Yeah, or tweet at me, that's fine too.
Or tweet, and we'll try to get your contact info up on the, well, yeah, we'll talk about how to get contact info. Yep. And then
hit that bell.
Subscribe. So anyway, yeah, thank you, Vicky, for sharing this with us. It's always great to hear updates about this work, and we look forward to seeing what comes next for ReproZip.
Yeah, thank you very much.
Thanks, Vicky.
Right.
Yeah,
thanks everyone.